Course Introduction. 1. Minimize the risk of fire. Theory of fire. For a fire to occur, the following conditions should be present: presence of materials which act as a fuel, a source of ignition, chemical, biological or physical, the presence of oxygen. Chemistry of fire. Oxidation is a chemical process in which a substance combines with oxygen. During the process, energy is given off, usually in the form of heat. Fire or combustion is rapid oxidation. The burning substance combines with oxygen at a very high rate. Energy is given off by the form of heat and light. Because this energy production is rapid, we can feel the heat and see the light as flames. The 2010 Manila Amendments to STCW Convention and Code, Section A-1 Paragraph 2.1.2. Seafarers employed or engaged in any capacity on board ship on the business of that ship shall, before being assigned to any shipboard duties, receive appropriate approved basic training or instruction in fire prevention and firefighting. Objectives. At the end of the module, the trainees shall know what to do if fire or smoke is detected. Fire alarm is sounded, raise the alarm and have basic knowledge of the use of portable fire extinguishers. Close and open weather and watertight doors. Fight and extinguish fires. Ship construction principles. A ship is the product of three main areas of skill: those of the naval architect, the navigating officer, deck officer, and the marine engineer, engineering officer. There are two main parts of a ship: the hull and the machinery. Basic ship construction principles. Class A, B and C divisions. Class A. Built in steel or other equivalent material suitably stiffened, built to be capable of preventing the passage of smoke and flame to the end of the 1 hour, insulated with approved non-combustible materials. Class B divisions. Constructed of approved non-combustible materials, built to avoid the passage of flames during at least 30 minutes of the standard test. Class C divisions. Constructed of approved non-combustible materials, without any particular requirements. Shipboard Firefighting Organization, General Emergency Alarm Signal. Consists of 7 short blasts followed by 1 long blast on ship's whistle, bell, horn, siren. Purpose: to alert the crew on board that an emergency has occurred. General Emergency Alarm Signal, located in the navigation bridge. What to do upon hearing: follow the instruction as indicated in the emergency plan and muster list. Fire alarm. Continuous ringing of fire alarm bell. What to do when fire is detected: activate it by pressing the nearest fire switch. Loud and continuous shouting of fire, fire, fire. Firefighting organization on board ships. Master has the overall responsibility for the operation during firefighting. Chief officer, in charge of operation in the accommodation and deck area. Chief engineer, in charge of operation in and around the engine room. Common emergency teams during firefighting operations on board: bridge team, attack team, support, engine room team. Bridge team. Located at the bridge. Also called operational command, command and control, etc. Led by the master together with OWA and helmsman. Intended to lead and coordinate all efforts and keeps a detailed time records of events in case of fire. Communicate with the entire firefighting operations. Attack team. Attack and fight fire under the direction from the bridge. Led by the chief officer as the on-scene commander in a fire emergency. Support team. intended to provide extra manpower by helping the attack team fetch equipment and breathing apparatus. Bring supplies of hose, nozzles, axes and spare cylinders to the staging area. Other tasks of the support team: providing first aid to injured persons, preparing lifeboats, life rafts for evacuation, recharging SCBA cylinders, conducting security patrols, providing boundary cooling. Engine Room Team. Located in the engine room team station. Led by the chief engineer. In some ships, also called technical department. Tasks of the engine room team: control the technical, mechanical and electrical devices needed to support the emergency response. Maintain and provide maximum readiness to engines and auxiliaries in the engine room. Control the operation of emergency pumps and generators. Topic number 2, Firefighting Appliances and Emergency Escape Routes. Emergency escape routes. Means of escape. A plan containing important information for rapid and efficient action of ship's crew during a fire. Permanently stored in a prominently marked with airtight enclosure outside the deckhouse. Fire control plans. Details that fire control plans must show: control stations. Various fire sections enclosed by A-class divisions. Sections enclosed by B-class divisions. Particulars of fire detection and alarm systems, sprinkler installation and fire-extinguishing appliances.
Details that fire control plans must show: means of access to different compartments, decks, etc. Ventilating system including fan control positions, position of dampers, identification numbers of the ventilating fans serving each sections. The fire control plan should be permanently exhibited for the guidance of ship officer in conspicuous locations such as navigation bridge, engine room, and accommodation. Muster list. Lists of duties and responsibilities in case of emergency assigned to each crew members on board. Displayed in every conspicuous location of the ship where crew spends the maximum of their time, like bridge, engine room, accommodation alleyways. Fire-fighting appliances.
Regulation 10 of SOLAS Chapter 2.2, Firefighting. The purpose of this regulation is to suppress and swiftly extinguish a fire in the space of origin. Fixed fire extinguishing systems shall be installed. Fire extinguishing appliances shall be readily available. Fire-fighting appliances.
Water supply systems. Ships shall be provided with fire pumps, fire mains, hydrants and hoses. Ships of 500 gross tonnage and upward shall be provided with at least one international shore connection.
Fire hydrant. Fire doors. Fire dampers.
Fire pump. Number of independently driven fire pumps in passenger ships of 4,000 GT or more, at least 3, less than 4,000 GT, at least 2. In cargo ships of 1,000 GT or more, at least 2, less than 1,000 GT, at least power-driven pumps, 1 shall be independently driven. Fire hoses and nozzles. Shall be of non-perishable materials. Hoses shall have a length of at least 10 meters but not more than 15 meters in machinery spaces, 20 meters in other spaces and open decks, 25 meters for open decks on ships with a maximum breadth in excess of 30 meters. Number in diameter fire hoses. Diameter 65 millimeters, 2.5 inches. 38 millimeters, 1.5 inches. Number in cargo ships of 1,000 GT or more, not less than 5 excluding those required in the engine room and boiler room. Less than 1,000, not less than 3. Number in diameter fire hoses. In passenger ships, at least one for each of the hydrants required by SOLAS and shall be used only for the purposes of extinguishing fires or testing fire-extinguishing equipment during drills and surveys.
Size and type of nozzles. Standard sizes shall be 12 mm, 16 mm and 19 mm. Larger nozzles may be permitted at the discretion of the administration. Shall be of approved dual-purpose type, spray/jet type, incorporating a shut-off. Portable fire extinguishers. Ships of 1,000 GT or more. At least 5 spare charges shall be provided for 100% of the first 10 extinguishers, and 50% of the remaining capable of being recharged on board. Types of fixed fire extinguishing systems. Fixed gas fire extinguishing system. Fixed pressure water spraying fire extinguishing system. Types of fixed fire extinguishing systems. Fixed high expansion foam. Use of halon is prohibited. Openings which may admit air to, or allow gas to escape from a protected space shall be capable of being closed from outside the protected space. Machinery spaces containing oil-fired boilers and those containing internal combustion machinery shall be provided with one fixed system. Sprinkler and water spraying systems. Passenger ships carrying more than 36 passengers shall be equipped with automatic sprinkler, fire detection and alarm system. All cargo ships shall be equipped with automatic sprinkler, fire detection and alarm system. Inert gas systems. Cargo spaces of passenger ships of 1,000 GT or more and of cargo ships of 2,000 GT or more shall be protected by fixed CO2 or inert gas fire extinguishing system. Cargo spaces of passenger ships of 1,000 GT or more and of cargo ships of 2,000 GT or more shall be protected by fixed CO2 or inert gas fire extinguishing system. Exemptions. If cargo spaces of cargo ship is constructed solely for the carriage of the FF, or, coal, grain, unseasoned timber, non-combustible cargoes, cargoes W.C. constitute a low fire risk. Firefighters outfit. Ships shall carry at least 2 firefighters outfits. In addition, passengers ships shall be provided, for every 80 meters, 2 firefighters outfits and 2 sets of personal equipment. If carrying more than 36 packs, 2 additional FFO for each main vertical zone. 2 spare charges for each required breathing apparatus. Passenger ships carrying more than 36 packs shall be fitted with the suitably located means of fully recharging breathing air cylinders. A minimum of 2 two-way portable radio telephone apparatus for each fire party of explosion-proof type. Portable radio telephone. Fire axe. SCBA. Hand lantern. Fireproof lifeline with snap hook. Topic number 3, Elements of Fire and Explosion, the Fire Triangle. Condition for fire. Elements of fire and explosion. The fire triangle. The fire triangle is a simple means of illustrating the 3 requirements for the existence of fire. It does not include the chain reaction that results from chemical reactions among the fuel, oxygen and heat. Elements of fire and explosion. Fire tetrahedron. A tetrahedron is a solid figure with 4 triangular faces. It is useful for illustrating and remembering the combustion process because it has room for the chain reaction and because each face touches the other 3 faces. Extinguishment via the fire tetrahedron. A fire can be extinguished by destroying the fire tetrahedron. If the fuel, oxygen or heat is removed, the fire will die out. If the chain reaction is broken, the resulting reduction in vapor and heat production will extinguish the fire. Once the chain reaction sequence is broken, a fire can be extinguished rapidly. The extinguishing agents commonly used to attack the chain reaction and inhibit combustion are dry chemicals. The effect of temperature rise on the rate of the chain reaction, that is fire intensity.